In my previous video, we have learned about everything you need to know about coordinate geometry. Have you watched it yet? If not, I suggest that you watch that video first and then you come back to this video. In this video, we'll be discussing about 10 years of past year question on Paper 1 Coordinate Geometry, and we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you'd like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the first past year question. Let's look at question number 1. This is SPM 2010, question 13. So a straight line passes through A, -2, -5 and B, 6, 7. A, given C, H10, lies on the straight line AB. Find the value of H. So to find the value of H, I'm going to use the gradient. So I'm going to use gradient of AC equals to gradient of AB. So gradient of AC would be 10 minus -5 over H minus -2. And it's equals to 7 minus -5 over 6 minus -2. Okay, let's solve this. So 10 plus 5 is 15, and H plus 2 equals to 7 plus 5 is 12 over 6 plus 2 is 8. Okay, now let's solve this. I'm going to flip it upside down for both sides so that my H will be on top. Okay, so this side also have to flip it upside down. Okay, so to find H, so this 15, I'm going to bring it over to the right hand side. So it becomes 8 over 12 times with 15, okay, which is equals to 10. So H plus 2 is equals to 10. So therefore, H is 10 minus 2, which is 8. So 8 is the answer. Okay, now let's solve for B. So for B, point D divides the line segment AB in a ratio of 1 to 3. Find the coordinates of D. So for this, I would draw a line, which is a number line. Okay, I would draw a line, and then I'm going to label the coordinates on the line so that it's easy for me to see. Okay, so we have A here, okay, and D is somewhere in the middle, and this is B, okay. So A is -2, -5. Okay, D, I let it to be XY. And B would be, is given as 6, 7 in the question. Okay, so divides in the ratio of 1 to 3. It means that the M is 1, okay, and this N equals to 3. So with this information given, okay, we can put into the formula. So D, okay, let it to be XY. So equals to, okay, so the formula, I'm going to write down the formula, okay. So N x1 plus M x2 over M plus N, comma, N y1 plus M y2 over M plus N. Then remember to put in bracket because it's a coordinate. So equals to, so N is 3, okay, x1 is the first coordinate, which is A, okay, so B will be the second coordinate, yeah? So x1 will be -2, okay, plus M is 1, then x2 is 6, then over M plus N, which is 1 plus 3, okay, then comma. So N is 3, y1 is -5, okay, plus with M, which is 1, and then y2 is 7, then over M plus N, so 1 plus 3. And then remember to put the big bracket because it's a coordinate. So equals, okay, let's solve this. -6 plus 6, we'll get 0. So the first coordinate is 0. Okay, and then next one, -15 plus 7 divided by 4, which is -2. Okay, so -2. So this is the answer for coordinate D. Let's look at question number 2. This is SPM 2011, question 13. A straight line x over 2 plus y over 6 equals to 1 cuts the axis at P and y axis at Q. Find A, the gradient of the straight line. and B, the equation of the perpendicular bisector of the straight line, and this is 3 marks. Okay, so from the equation given, we can actually find the gradient. So for A, okay, so you see x over 2 plus y over 6 equals to 1. So the 2 is actually the x-intercept. Okay, and the 6 is actually the y-intercept. So if you want to find the gradient of the straight line, is actually, so the gradient, yeah? So gradient, I'm going to write it over here, okay, of the straight line is actually negative y-intercept. This is a formula, okay, over x-intercept. So if the intercept is given, then we use this formula to find the gradient. So which is equals to negative 6 over 2. And the answer is negative 3. Okay, now let's solve for B. Okay, B, the equation of the perpendicular bisector. So the keyword is perpendicular bisector, which means we have to find the midpoint. And then after that, we're going to use m1, m2 equals to negative 1 to find the gradient of the normal. Okay, so we try to sketch the graph first, okay, and see how it looks like. So we have the intersection, okay, y-intercept is 6 and x-intercept is 2. So we have a straight line over here, like that, okay? So this is the y and this is the x. Okay, so I'm going to find the midpoint for this line. So the midpoint, okay, of PQ. So this is P and this is Q. Okay, so the midpoint of PQ will be, so 0 plus 2 over 2 and 6 plus 0 over 2. So 2 over 2 is 1 and 6 over 2 is 3. Okay, the next step is to find the M2. So for this line, the gradient of PQ, okay, is negative 3 that we have found just now in A. And then we have to find the normal, which is M, okay, M1, M2 equals to negative 1. We're going to use this. So M1 is negative 3, okay. So M2, we don't know. I'm going to put it inside here. So our M2 is negative 1 over negative 3 is 1 over 3, okay. So the last step is to put into the equation of the straight line formula, which is y minus y1 equals to mx minus x1. So I'm going to use this coordinate and this gradient and put into the formula. So y minus 3 equals to 1 over 3 x minus 1. Okay, then I'm going to move this 3, this 1 over 3, I shift it to the left, it becomes times 3 for all. So it'll be 3y minus 9, okay, equals to x minus 1. Okay, and then next, I'm going to move everything to the right, so it becomes 0 equals to x minus 3y. And then negative 1 plus 9 is 8, so plus 8. Okay, so I swap it over because I want my answer to be in general form, so equals to 0. Okay, so this is the final answer for B. Let's look at question number 3. This is SPM 2012, question 13. Diagram below shows a straight line AB. Find A, the midpoint of AB, and B, the equation of the perpendicular bisector of AB. So the first step is to find the midpoint. Okay, after that, the next one for B, we have to use M1, M2 equals to negative 1 formula to find M2. Okay, so let's solve for A first. Yeah? So for A, we're going to find the midpoint of AB. So midpoint of AB. Okay, so it's equals to, I'm going to use x1 plus x2, which is 15 plus negative 1 over 2, okay? Then y1 plus y2 over 2, so it'll be 7 plus 3 over 2. So 15 minus 1 is 14, 14 divided by 2 is 7, and 7 plus 3 is 10, 10 divided by 2 is 5. So that's the answer for A, 7, 5, okay? So now let's solve for B. Okay, so for B, we have to find what is the gradient of AB first. So to find the gradient of AB, I'm going to use y2 minus y1 over x2 minus x1. Okay, so 7 minus 3 is 4. 4 over 16 is 1 over 4. After that, I need to find what is the normal. So I'm going to use m1, m2 equals to -1. So m1 is 1 over 4, so m2, okay, will be, so m2 equals to -1 times 4 would be -4. So I'm going to use this, okay, I'm going to use the midpoint and the m2 to put into y minus y1 equals to mx minus x1 to find the equation of the perpendicular bisector of AB. So y minus 5 equals to -4x minus 7. So y minus 5 equals to -4x plus 28. Okay, so we'll get y equals to -4x, okay, plus, so 28 plus 5 will get 33. So plus 33. So this is the final answer for B. Let's look at question number 4. This SPM 2013, question 13. Diagram below shows a straight line AB. Given M is the midpoint of AB, find A, the coordinates of M, and B, the equation of the straight line which is perpendicular to AB and passing through M. So first I need to find what is the midpoint. Okay, so midpoint of AB. So I'm going to use x1 plus x2, okay, which is 0 plus 2 over 2, and then y1 plus y2 over 2, that will be 4 plus 0 over 2. Okay, so 2 over 2 is 1, then 4 divided by 2 is 2. So that's the answer for A. Okay, now let's solve for B. So to find B, we need to find the M2. Okay, before that, we find what is the gradient of AB first. So gradient of AB, okay, which is MAB, so equals to y2 minus y1, which is 4 minus 0, over x2 minus x1, 0 minus 2, so we get -2. Okay, so after that, I'm going to find the normal, so which is m1, m2 equals to -1. We're going to use this formula. So m1 is -2, okay, times with m2 equals to -1. So to find m2, okay, -1 divided by -2, we'll get 1 over 2. Okay, so we're going to use the midpoint, which is 1, 2, and this gradient, which is 1 over 2, and put into the formula, which is y minus y1, okay, equals to m bracket x minus x1 to find the equation of the straight line. So y minus 2 equals to half x minus 1. Okay, so the 2 I bring over to the left hand side, so it become 2y minus 4 equals to x minus 1. Okay, so after that we'll get 2y equals to x, so -1 plus with 4, so we get +3. Okay, so we can leave this as the final answer. Let's look at question number 5. This SPM 2014, question 12. The diagram below shows a straight line PQ with equation x over 5 plus y over 7 equals to 1 intersects the straight line AB at point P. A, state the y-intercept of PQ, and B, find the coordinates of B if BP is equal to 2PA. Okay, let's solve for A first. So it's given that the equation is x over 5 plus y over 7 equals to 1. And you see, this is y-intercept. So we straight away can get the y-intercept, okay, which is equals to 7. That's the answer for A. Okay, let's solve for B. Find the coordinates of B. Okay, B is over here, so I let it to be xy, okay, if BP is equals to 2PA. So if I want to find the ratio, this I let it to be 1, okay, so this 2 shift over to the left hand side to be 1 over 2, then BP, I shift it over to the right hand side, become over BP, okay, which means that PA, okay, the ratio is 1, which means that the M is over here equals to 1, and then BP, okay, BP is over here, which is N equals to 2. Okay, so we got the ratio already, so we can find the coordinates of B. Okay, so P for B, I'm going to continue over here. So the P, which is 5, 0, okay, equals to, okay, I'm going to put it into the formula, which is N. Okay, N, I write down the formula first, okay? So that some of you are not familiar with the formula, you write the formula. So if you write the formula many times, soon it will get into your head, okay? So mx2 over m plus n, okay, comma, ny1 plus my2 over m plus n. So I'm going to substitute the values here. Okay, so the A will be x1, y1, the B will be x2, y2. Okay, so equals to, so the n is 2, okay, x1 is 3, m is 1, then x2 is x, then over m plus n, which is 1 plus 2. Okay, then comma, so n is 2, okay, y1 is -4, plus m is 1, and y2 is y, then over 1 plus 2. Okay, then remember to close bracket because it's a coordinate. Okay, then after that, I'm going to bring out the x coordinate, which is 5, okay, and compare with the coordinate p. So 5 equals to 6 plus x over 3. Okay, so we can solve the value of x. So we bring over the 3, become 15. 15 minus 6 is 9. So x is equals to 9. Okay, so next one, I look at the y coordinate, which is 0. Okay, so 0 equals to, so -8 plus y over 3. So when I bring over the 3, it becomes 0. Then I bring over the -8, it becomes +8. So therefore, y is +8. So now we have the coordinate b, okay, which is 9, 8. So that is the answer. Let's look at question number 6. This SPM 2015, question 11. The equation of the straight line is given by px plus qy minus 1 equals to 0, where p and q are constants. Find, in terms of p and q, a, the gradient of the straight line, and b, the gradient of the straight line which is perpendicular to the line px plus qy minus 1 equals to 0, and it's 2 marks. Okay, let's solve for a first. So the equation that they give in the question is px plus qy minus 1 equals 0. So we are going to change this into y equals to mx plus c, okay, into that form. So qy equals to negative px plus 1. So y equals to, I bring over the q, so become negative p over q x plus 1 over q. Okay, so now we have in the form of y equals to mx plus c. So therefore, the m, the gradient, is this. Okay, so I'm going to write the gradient, okay, which is the m, is equals to negative p over q. Okay, so that's the answer for A. So now let's solve for B. The gradient of the straight line which is perpendicular to the line. So perpendicular to the line means we have to use the formula m1, m2 equals to -1. Okay, so m1 is negative p over q, then times m2 equals to -1. So to find m2, I'm going to shift over the negative p over q to the right hand side. So we will get q over p, and that's the answer for B. Let's look at question number 7. This is SPM 2016, question 9. Diagram below shows two straight lines on the Cartesian plane. Both the straight lines are perpendicular to each other. So A, state the value of Q, and B, find the coordinates of F. Okay, so to solve A, okay, so the first one, this is the equation 1, okay, and this is the gradient, which is 3, and this will be the gradient, which is M2, okay, because they are perpendicular to each other. So I'm going to put into M1, M2 formula, okay, equals to -1. So M1 is 3, okay, times with M2, which is Q, equals to -1. So therefore, Q is equals to -1 over 3. So that's the answer for A. Okay, now let's solve for B. Find the coordinates of F. So F is the point of intersection between the two lines. Okay, so the first equation is y equals to 3x plus 4. This one I take it as equation 1. And then equation 2 will be y equals to q is -1 over 3, okay, x minus 6, and this equation 2. Okay, so I'm going to use simultaneous equation method to solve these two equations to find the x and y. So it will be 3x plus 4 equals to -1 over 3x minus 6. Okay, so to eliminate the denominator here, which is 3, I'm going to multiply by 3 for all the terms, okay, on the left and right. So it becomes 9x plus 12 equals to -x minus 18. So 9x plus x equals to -18 minus 12. So this will be 10x equals to -30. So therefore, x is -30 divided by 10 is -3. Okay, now we have to find the coordinate for y, coordinate of y. So I'm going to substitute, okay, x equals to -3 into equation 1, because equation 1 is easier, there is no fraction. Okay, so equation 1 will be y equals to 3x plus 4, which is 3, -3, then plus 4. So equals to negative 9 plus 4, which is equals to negative 5. Okay, so therefore coordinate F is negative 3, negative 5, and that's the answer. Let's look at question number 8. This SPM 2017, question 18. A straight line passes through P 3,1 and Q 12,7. The point R divides the line segment PQ such that 2PQ equals to 3RQ. Find the coordinates of R, and this is 3 marks. So I'm going to write this down first to find the ratio. Okay, 2PQ equals to 3RQ. So if PQ over RQ, then will be 3 over 2. Okay, so now I'm going to draw a line segment, so that we can see clearly where are the coordinates. Okay, and also we can label the ratio. Okay, let's say this is the line. So here will be a P. Okay, P is 3,1, and then Q is over here, which is 12,7. Okay, R is somewhere in the middle, but it's not exactly in the middle, okay, in between P and Q. So I label as XY because it's unknown. Okay, now we label the ratio. So PQ is 3 and RQ is 2. So RQ is 2 parts, so therefore N is 2. Okay, and then P to Q is 3 parts, therefore M is equals to 1, because total parts is 3 parts. Okay, so now we can put into the formula, okay, which is RXY, okay, equals to Nx1 plus Mx2 over M plus N, comma, Ny1 plus My2 over M plus N, and then close bracket. Okay, so here will be your first point, which is x1, y1. Here will be your second point, which is x2, y2. Okay, so now we can substitute the values into the formula. So N is 2, okay, x1 is 3, plus M is 1, okay, x2 is 12, then over M plus N, which is 1 plus 2, then comma. So N is 2, and y1 is 1, then plus M is 1, and y2 is 7, then over 1 plus 2, close bracket. Okay, so now let's solve this. So 6 plus 12 is 18. So 18 over 3. And this is 2 plus 7, which is 9. 9 over 3. Remember your bracket because it's a coordinate. So therefore, the answer is 6, 3. So that's the answer. Let's look at question number 9. This SPM 2018, question 10. The following information refers to the equation of two straight lines, AB and CD. For AB, y minus 2kx minus 3 equals to 0, and CD, x over 3h plus y over 4 equals to 1, where h and k are constants. Given the straight lines AB and CD are perpendicular to each other, so the keyword here is perpendicular. So when we see perpendicular, we are going to use this formula, m1, m2 equals to negative 1. Okay, so now let's solve this. For AB, we find what is the gradient. Okay, so the equation given is y minus 2kx minus 3 equals to 0. Okay, I'm going to change it to the form of y equals to mx plus c to find m. So y equals to 2kx plus 3. Okay, therefore, the gradient of AB is equals to 2k. Okay, now for CD, so it's x over 3h plus y over 4 equals to 1. So to find the gradient of CD, we're going to use the negative y-intercept over x-intercept. So negative y-intercept is 4, okay, over x-intercept is 3h. Okay, so the gradient for CD is negative 4 over 3h. So now we can substitute into m1, m2 equals to negative 1. Okay, which means MAB times with MCD equals to negative 1 because they are perpendicular to each other. Okay, so let's solve this. So 2k, okay, times with negative 4 over 3h equals to negative 1. Okay, so let's solve this. 2k times with negative 4 is negative 8, negative 8k. So the 3h shift over to the right hand side become negative 3h. So they want your answer to be h in terms of k, which means that h on the left hand side and k on the right hand side. Okay, so h will be, so the answer, okay, h, so the negative 3 shift over to the right, okay, to shift over to the left, so it becomes positive 8 over 3, so it's 8 over 3, okay, and k. So this is the answer, which is express h in terms of k, so therefore h equals to 8 over 3k is the answer. Let's look at question number 10. This is SPM 2019, question 14. Diagram below shows 3 straight lines such that K, P, Q, and R are constants. Express A, K in terms of Q, and B, R in terms of K and P, and this is 3 marks. Okay, so this equation belongs to this line, okay? So I'm going to label this as x0, okay? This point will be 0y. Okay, so let's solve this for A. So at the point which is 0y, okay, so at this point, so when x equals to 0, okay, so I'm going to substitute x equal to 0 into this formula, which is x over p minus y over q equals to 1, because it lies on this point, lies on this line, okay? So for here, so when x is 0, so it will be 0 over p minus y over q equals to 1. Okay, so 0 over p is 0, so negative y equals to q. So therefore, y equals to negative q. Okay, so we put this aside. Okay, then after that, at. Okay, so it's now the y equals to negative q. So at 0, negative q, which means here is negative q. Okay, so at here, I'm going to substitute into the second equation, which is ky equals to 3x plus 6. Okay, so I'm going to substitute these values inside. So k, the y is negative q, equals to 3, the x is 0, plus 6. So negative kq, okay, equals to 6. So now let's look at the question. They are asking k in terms of q, which means that k should be on the left hand side. So negative k equals to 6 over q. Okay, so therefore k is equals to negative 6 over q. So that's the answer for A. Okay, now let's solve for B. Yeah? Okay, so for B, okay, so when R in terms of K and P, so when, okay, at x0, okay, which is here, yeah, so when y equals to 0. So I'm going to substitute into this equation, okay? So it will be x over p minus y over q equals to 1. So I'm going to substitute y equals to 0 inside, okay? So x over p minus 0 over q equals to 1. So x over p equals to 1, okay? So x is equals to p. Okay, so now I have this x is p. Okay, so this r over here, so I'm going to label as 0, r. Okay, so I'm going to find the gradient of these 2 points, this, okay, and this. Okay, so I have the 2 points, which is 0, r and x0. So I'm going to find the gradient m1, okay, so it will be r minus 0 over, okay, so this x is p, okay, so it will be r minus 0, so 0 minus p, okay, so which is equals to negative r over p. Okay, then as for this equation, okay, the gradient, that would be the m2, so I'm going to write it over here, so it will be ky equals to 3x plus 6. So I change it in the form of y equals to mx plus c, so it will be 3 over k, x plus 6 over k. So therefore, my m2 is 3 over k. Okay? So since both of the lines are parallel to each other, therefore m1 equals to m2. Okay, which means that, okay, m1 equals to m2. Okay, so just now m1 we got here, negative r over p, okay, equals to m2 is here, which is 3 over k. Okay, so now we have to find r in terms of k and p, which means r must be on the left hand side. So negative r equals to 3p over k. So to find r, I'm going to move the negative over to the right hand side, become negative 3p over K. So that's the answer for B. Well, that's all for now. Stay tuned to my next video, which is 10 years of past year questions on Paper 2 Coordinate Geometry, coming up soon. Bye!